Okay, so we're going to keep going in this second trig packet. So we are going to build on what we learned already about the signs in the different quadrants and about SOHCAHTOA. So we're going to go to page 3 and we're going to do example 3 together. So we can be given information about one trig function and ask for others. So we're going to start off drawing a picture. And they kind of like to pick questions similar to this on the ACT. So this is really good practice for the ACT. So on A, we know that the sine of theta is 12 over 13. And we know that theta is in quadrant 1. So let's just go ahead and start off with a picture. So we're going to go ahead and draw quadrant 1. And we'll get a triangle in there. Theta is here. Now what we know is that the sine of theta is 12 over 13. So the sine is the opposite over the hypotenuse. So it's telling us that the opposite is 12 and the hypotenuse is 13. Now this is actually a Pythagorean triple that you may or may not know. If you do know it, it's going to save you some time. If you don't, we can use the Pythagorean theorem to figure it out. Now, if we are looking for the hypotenuse on the Pythagorean theorem, we're going to add. But if we have the hypotenuse, we're going to subtract. So I'm going to say what we're looking for here is x, since it's a horizontal distance. So x squared should be equal to our hypotenuse squared minus the other leg squared, which would be y. All right, so that's going to be 169 minus 144, which is going to be 25. So that is going to make x 5. So 5, 12, 13 is the Pythagorean triple. Knowing that definitely is going to save you some time. Now what we want to find from this triangle is the cosine of theta and the tangent of theta. Now since our triangle is in quadrant 1, those are both positive. So for cosine, we will do the adjacent over the hypotenuse. And then for tangent, we'll do the opposite over the adjacent. Okay, then for B, this time we know that the cosine of theta is 2/3 and that theta is in quadrant 4. So that means that the adjacent is 2 and the hypotenuse is 3. Okay, so again, we know the hypotenuse, so we're going to subtract on the Pythagorean theorem. And since this is a vertical leg, I'm going to call it y. So y squared should be equal to the hypotenuse squared minus the leg we're looking for squared. So that's going to be 9 minus 4 or 5. So y squared is 5. So y is the square root of 5. Okay. And we're looking for the sine of theta and the tangent of theta. So in quadrant 4, the sine and the tangent are negative. So we'll just go ahead and do negatives. Right, for the sine, we'll do the opposite over the hypotenuse. And for the tangent, we will do the opposite over the adjacent. And that is it. All right, then for C, we know the tangent of theta is 3, and theta is in quadrant 3. Now there's more than one way to set this up. There's more than one way to set all of these up, but we just know that on this, when we divide the opposite by the adjacent, that we get 3. So there's lots of numbers that divide to get 3. It could be 12 and 4. It could be 6 and 2. The simplest way to do this is to use the most reduced one, which would be 3 over 1. It's not really reduced, but the simplest numbers we could use to divide and get 3 are 3 and 1. All right, this time we are looking for the hypotenuse, so we will add. So r squared is equal to 3 squared plus 1 squared, or r squared is 10, so r is the square root of 10. All right, so we want to find cosine of theta and cosecant of theta. So the cosine in quadrant 3 is negative. The cosecant is the reciprocal of the sine, and the sine in quadrant 3 is negative also. So for cosine, we will do the adjacent over the hypotenuse, or negative square root of 10 over 10. Now the cosecant is reciprocal of the sine, so instead of opposite over hypotenuse, we'll do hypotenuse over opposite. All right, and then on D, we know that the cosecant is 6 over 5. Now, we don't know what quadrant we're in. We do know that the cosecant is the reciprocal of the sine, and sine is positive because it tells you the cosecant is positive 6 over 5. The sine is positive in quadrants 1 and 2. So this has 2 possible triangles. Kind of looks like a butterfly. Not a good one though. So for the cosecant, this is going to be the hypotenuse over the opposite. Okay. Then since we have the hypotenuse, to find a missing leg, we're going to subtract the hypotenuse squared minus the leg that you know squared. So 36 minus 25 is 11. And so those legs are the square root of 11. All right, so we're going to find the cosine of theta and the cotangent of theta. Now, in quadrant 1, cosine is positive, but in quadrant 2, cosine is negative. So we're going to do plus or minus. Do the same thing with cotangent. All right, so cosine will do the adjacent over the hypotenuse. And then cotangent is reciprocal of tangent, so we have the adjacent over the opposite. All right, and then for example 4, we are just going to use the rule that we talked about yesterday. All students take calculus to answer some questions. And don't forget that all students take calculus tells you where the trig ratios, original 3 trig ratios are positive, and then the quadrants go around in that same order: 1, 2, 3, 4. All right, so on example 4, the sine is positive and the cosine is negative. So that should happen where sine's positive and cosine's negative is the S part, which is the student's part, which is number 2. All right, then we have the secant is negative. Now that's not the same S as this S, because that S is talking about sine, the original 3. So we would want to write down that this means that the cosine is negative. All right, and then for cotangent, that means the tangent is negative. So we want to find a quadrant where cosine and tangent are both negative. That's going to be quadrant 2. Because only sine out of the original 3 is positive in quadrant 2. The other 2 are negative. So once you get out of quadrant 1, we're talking about the original 3 trig functions. 1 will be positive, 2 will be negative. All right, and then for this one. Cosecant is negative, so that means the sine is negative, and cosine is positive. So look at that for a second. That's going to be quadrant 4. All right, and then for D, we want all trig functions negative. There is no quadrant where that happens, so we would just say none. All right, we are going to skip some numbers. We're going to go all the way to page 7. We're going to talk about coterminal angles. So far, all of our angles have been between 0 and 360 degrees, but there are angles that are outside of that range. So we are going to find that a full rotation is 360 degrees, so we can do a full rotation and then a little bit more and create an angle that's greater than 360. We also can have negative angles we haven't talked about in this packet. So what we're going to find, so we can figure out kind of what's going on with these angles, is find a coterminal angle. And coterminal angles are found by adding or subtracting 360 degrees or 2 pi from any angle. And it doesn't give you the same angle, but what happens is the sine and cosine and tangent of those angles are the same. So they're coterminal, so they're different, but they have the same trig ratios. All right, so what we'll do for example 7 is we're going to find a coterminal angle between 0 and 360, and then we're going to figure out the signs of the 6 trig ratios, not what the actual ratios are, just if they're positive or negative. And we're going to do this just by adding and subtracting 360 degrees. So if the number is bigger than 360 degrees, to find the coterminal angle, we subtract 360 degrees. So that gives us a coterminal angle of 40 degrees. Then we have to figure out what quadrant 40 degrees is in. So down here at the bottom, I'm just going to draw quadrants. So we have 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then all the way around we get back to 360 degrees. Those are the quadrant angles. All right, so 40 degrees obviously falls in between 0 and 90 degrees, so that's quadrant 1. And in quadrant 1, all of the trig ratios are positive, so that's easy. Okay, then for 850, we'll subtract 360. Right, and then that's still too big, so we'll subtract 360 again. And that gives us 130 degrees. 130 degrees is in quadrant 2. Okay, so we have to remember all students take calculus again. So quadrant 2 is the students, so sine is positive, and the other 2 trig ratios are negative. And so that reflects over here with the reciprocals. Cosecant would be positive, and then the other 2 will be negative. All right, and same thing on 1,275 degrees. So just keep subtracting 360 degrees over and over and over again until we get an angle that's between 0 and 360, and that angle is 195 degrees. And 195 degrees is in quadrant 3. Right, quadrant 3 is the take part of all students take calculus, which means tangent is positive and the other 2 are negative. And then we'll reflect that with the reciprocals. All right, for negative angles, what we'll do is add 360 to it. That's going to give us 129 degrees. 129 degrees is in quadrant 2. Sine is positive, other 2 negative. Cosecant is positive, other 2 negative. Okay, then for negative 721, we add 360, add 360 again. We get 359 degrees, which is in quadrant 4. Quadrant 4 is the calculus part of all students take calculus, which means the cosine is positive, the other two are negative. That means the secant is positive and the other two reciprocal functions are negative. All right, and then for 17 pi over 3. 17 pi over 3 is in radians, not necessarily because it has a pi, but because it doesn't have a degree symbol. So what we would want to do is change it to degrees, because the directions say an angle between 0 and 360 degrees, so that means that angle must be in degrees. So we'll multiply by 180 degrees over pi, which is going to cancel the pi. So what we would want to do then is do 17 times 180 divided by 3. That's going to be 1020. And then just start subtracting 360, keep subtracting 360 until you get an angle in the range we're looking for between 0 and 360. We get 300. 300 is in quadrant 4. Quadrant 4 calculus, or is the calculus quadrant, which means cosine is positive, other two are negative, secant is positive, other two are negative. All right. So what I want you guys to do for this assignment is on page 8 through 10, I want you to do numbers 2, 3, and 7. Now there is one out of those that you can't really figure out yet. So let's look at it. All right, so I think it is 2.5 pi. So as you do that one, just keep in mind that that's kind of a strange situation. So if it works out weird, just don't worry about it. We will talk about it later. All right, so you're going to do number 7 on page 10. You're going to do number 3 on page 9. And then 2 is on page 8 and 9.